Hey there, I'm Said. In the previous episode, we discussed how we can grab a simple static mesh without any physics simulation afterward, and it was maybe one of the first steps that we need to make an interactable objects. In this episode, we would like to discuss one of the interesting interactions that maybe it's not necessary as a basic concept, but it's fun, and I decided maybe it's good to have it right now. However, we will simplify the actual implementation, but even with that one, I think it would be very nice. The way that we would like to interact with this object is called gravity gloves or Grabbity gloves that mainly introduced in Half-life Alyx. The way that we are doing this is we would like to have an object that moves towards our hand. It means we can grab objects from distance. In order to do this, we need to first find out which objects we would like to grab. For example, I'm planning to grab this green shallow cube. How I can find this? We have something in our game engine that also exists in most of the game engines called tracing for the objects. It means when we have this object, we can trace for it from the eye. We start from one point and then we will trace for all the object that is visible to that direction. We need the start position, the end position, and the way to trace for this one. For example, here we can have either a point trace that start from one point and reach to another point, but it means it's very sensitive to the position of the hands or position of the camera, or more accurately, the start position of the tracing. Or we can trace by the shape. For example, we can trace by the sphere. It means at the all time it's searching for different spheres until it reaches to the one certain point of this object. If any point on this surface, on this sphere, can touch this cube, it means we already traced that object and we can interact with that. Okay, good. What's the next step? The next step is we found the object that we want to track and we need to move it to our hand. We can do it with different ways, either using timelines or moving it actually with transfer method. That here I make it even simpler, that in a tick method we are just moving this object toward hands. As a summary, we need two steps: tracing for the objects and then transferring to the hand. However, it has many small steps in between that we will go together to find out what we need for it. It means that the main things that we need is tracing for that gravity available actor. I call it a trace for gravity actor. I made this function inside hand skeletal actor that previously we created. In this way, we can trace for the gravity actor separately for each hand. But the starting position and the end position is the same, but they can separately trace for this. You can also implement this method inside the VR character, but here I decided just to have it here. As I mentioned, if we can double check the figures that we had, we need a starting point. The starting point for us is the camera. And we can use the camera manager or player camera manager and getting the active camera for player index 0 and using the location of that camera as a start point. And then we can get the endpoint, which is the camera plus the forward vector of camera multiplied by maximum distance of tracing. We can then save the result of trace in something called fhit result. This fhit result can be saved in the array to have also multi-tracing. Here I'm creating a t-array of fhit result, calling it hit results. Also, in order to be able to distinguish between debugging mode and non-debugging mode, I made a boolean here that's called bShowDebugTrace. If it's active, it's showing you the debug for one frame, otherwise it doesn't show any debugging. Okay, that's good. Now we can start our tracing. We can use the Kismet system library and use the sphere trace multi. It has normal sphere trace, which is the single sphere trace, and also multi sphere trace that here we are using the multi. We're getting the word, and from the start position to the end position with the radius that we can define as a parameter. Also, we define it as a U property to be able to modify it later if we need. Also for the separated channel, which is the trace channel, if you check it inside our header file, you can see it's a enum of the type of the trace type query, and you should be always use tenum as byte if you want to use it as a U property. And then after we received all the results, also, I should mention we are not ignoring any actors, but we can also create the list of actors that you want to ignore, and we are saving everything in the hit result. And the debug trace type that we mentioned before is used here. We are not also tracing for the complex shape because, yeah, it's increased the workload and we do not need it. When we save the result in the hit result, we can go inside the hit result, and if the hit result is 0, then we should check whether we already find an actor that is ready for the gravity grab or not. If we have such this actor, then we can use that actor and cast it as Interactable, and we will deactivate the hover. I will discuss what this means, but in the general, when we do not find any hit results, we can put the ready for grab as a null pointer and also the component as a null pointer. Okay, but when we find something, we should go to the for loop or for each loop in more accurate way. And we are getting all the actors that we already found. And if the actor is implemented the class of our interactable interface, then we are casting that one into the Interactable. And using this Interactable, we are checking whether this actor is possible to be used for the gravity grabbing. What is this method here? If we are go into the Interactable interface, I defined some additional methods here. The first one is returning a boolean that says, okay, whether this interactable actor is gravity able or not. If it's the gravity type, then it returns true. Otherwise, it returns false. And by default, it's also returning false. In case we need it, we will implement this and returning true. And also, we have two methods for hovering when we are hovering over the objects and when we end hovering, and also when we press the grab for the gravity actor and when we release the grab button on gravity actor. These two methods is similar to the proximity grabbing. I'm now calling them proximity grabbing to be able to distinguish between gravity grabbing and proximity grabbing. Okay, when we check whether this actor is already gravity enabled, then we can go inside our if statements and saving our hit result as a gravity actor and gravity grab component. Also, if this one is enabled, then we will begin our hovering. It's the step that we are doing. And if it's not like that, we are just saving null pointer or assigning null pointer into our actor and components of gravity. By activating the gravity hover begin, we are calling something on that actor that we will go into it later when we discuss the actor implementation. But the next step that we can do here inside our hand skeletal mesh is toggling the gravity grabbing. Because previously we were using our hand as a proximity grabbing, and I would like to deactivate and active that condition. In that way, I defined the interaction method for our hand. This one is enumerator, and it has for now at least two types, proximity and gravity. When we are touching the yellow area of our hand, we can switch between proximity and gravity. Just the proximity is working like before, whatever we had previously, but the gravity will do our new functionality. The point to distinguish between them is coming to the material parts. I define the emissive power for that and overlay color. If we check the material for our hand, we can go here inside the VR characters to the models VR hands, and sorry, in the blueprints VR hands. And for the nanoid parts, that is our detailed mesh, we are using a material that has the possibility to receive the overlay color and emission power. This overlay color and emission power will define the color of the yellow area, somewhere like this. And also they can define the emission. I will just quickly do the demonstration for you. If I change the color and define some emission, you can see it start glowing, and our hand also glows like this. It's very beneficial to show when is the switching condition. And we can call these two parameters directly from our C++ code. As you can see, we are using set scalar parameter value and set vector parameter value to set to these two things. The color for the proximity and gravity condition is defined by two arrays. One of them is for emission power and the other one for the overlays color. If we check our mesh or our class mainly, we can search for the overlay. And as you can see, we now have here the overlay colors. This array contains of two elements. The first one is yellow for the proximity grabbing, and the other one is blue for the gravity grabbing. And also I added another particle system for gravity grabbing that's just spawning some particle with the shape of the hand that's using a skeletal mesh shape that shows we are in gravity grabbing mode. We should activate and deactivate this particle system according to the interaction mode as well. And when we have these two interaction modes, then we can also decide what should we do when we are pressing the grab button. And we will switch accordingly. I can explain in more detail if I open our VR character base. And here, when we are pressing the grab button, as you can see, we have the updating right hand pose. And after that, if this one is pressed already, we can call the right grab pressed, otherwise we are releasing it. But when we are calling this method can do the grabbing for us, and this grab pressed is coming here and checking whether we are in proximity condition or gravity condition. If we are in proximity condition, it's do whatever we discussed in previous episode about proximity grabbing, and if it's in the gravity mode, it's casting our ready to gravity grab actor, the actor that we have, into the Interactable interface, and inside that we will call gravity grab pressed, and this method will do all the tricks for us for doing the gravity. Also, we are saving it into the attached gravity actor if it's activated. And also we will deactivate the effects that we already shown for the hand, this particle system, because it's not reasonable to keep them active after we already finished with the grabbing process. Okay, now if we go inside the actor that this one is implemented in there, we can find out how we can implement this gravity grab pressed. Previously we had this simple pickup static mesh, but for this episode we can also have another type of the blueprints or interactable objects called Grabbity grab static mesh. This file is very similar to the simple pickup, just it implements some additional features that we need for gravity grab. One of them is Niagara components that show some effects when we are hovering over the objects. I can show you in this way that if here I open the Grabbity grab, you can see I added some particle system to the objects that can interact according to our hand position. The direction of these particles is following the hand, not now, but inside the game mode, and I will show you how we can implement it in code. The other component that we have is a skeletal mesh placeholder. That is this object. We will use this object to indicate the position of the hand when we are grabbing this object. It's very handy because you can use control rigs to define the shape of the hand, and also then you can position the hand, and it automatically goes at the correct position when you are grabbing the object. The other things is Grabbity grab duration, because it takes time to move from this location to the hand, and we can define this time. There are different ways, as I mentioned, but I would like to define it as a time for now to make it simpler. Also, we have different stage for our Grabbity condition. This stage defined as an enum here. It's either default, hovering, transferring, or already grabbed for our objects. That's it. We need also some simple float or vector variables that we will discuss later. But also we can save a reference to the hand that grabs that object, and also the actor that is covering or grabbed that object actually. The other things that we need is several methods according to the hovering start or hovering begin, hover ends, grab press, grab release, and two methods that I bring them here, but we do not need them. Maybe later if it's needed we can also use them. They are mainly for proximity grabbing. If you go inside the C++ file, I will bring it to the right hand side as usual. We have our constructor that defines the static mesh or create this static mesh. Then we are creating our Niagara component, and this one is hidden by default. Also the skeletal mesh is hidden by default, and it should not have any collisions. Both of them should attach to the static mesh, and the static mesh is a root of this class or this object. Let's start with hover begin. When we are looking at our object, there should be something that indicates this object is ready to interact. And we define this with this hovering method. When we are hovering over the object, if the Grabbity stage is not default, it means it's in condition either it's transferring to somewhere, or it's already grabbed, or it's already under hover mode, we should return. We should not do anything. But if we are in the default stage, then we set the Grabbity stage to the hovering, because we already left the hovering, and then we are saving the hand that hovers over the objects here, and we are setting the Niagara to be non-hidden. And afterwards, we are updating the Niagara component, the direction of this Niagara component according to the hand position. We can also do it in a tick method, but I did not do this here. Maybe you can test it yourself to always follow the hand, but just do it one time or in the one frame. And the way that it's doing this, it's related to the Niagara definition that we have. If we open this Niagara, I'm not going into the detail of the Niagara implementation, but it's just simple. It's just spawning some cubes, and they have a specific velocity. This velocity has a direction vector and speed that's defined by direction multiplier. But the direction is defined by the direction between our hand mesh components and the actor location. And we are getting safe normal of them and saving them as a direction parameter of our user defined parameter for Niagara system. As you can see, it's user and direction, and we should define them like this. Okay, it's updating our Niagara vector position. If Grabbity stage is equal to hovering, and we have the hover hand, we can update this Niagara component direction, as you can see here. Okay, great. The next point is when the hover ends, we should also do something accordingly to check first of all whether we were in the hovering mode or not. And if we were in there, we set the gravity stage to the default. It means when the eye direction is moved to another object, or if we do not find this object, we should deactivate the Niagara system, and also we are removing the reference to the hand. When we are pressing the grab button, we first check whether we are in transferring mode or grabbed mode, and if we are in these two states, we should return. Otherwise, we are saving a reference to the hands that we have, and we deactivate the physics simulation for that static mesh. Then we put our condition to the transferring. This condition will be used in the take method to move our object later. Also, I will save the initial gravity location and rotation of our placeholder in order if we need them later. Also, in the release condition, we are doing the reverse wise, and we are checking whether we are in the transferring or grab mode, because for example, if you release the grab button in the middle stage, the object should drop down. In this way, we should also check, even if it's in the transferring mode, the physics simulation should be activated, and then we should lose the reference to the hand, and condition should return to the default mode, and we are detaching from the actor. Okay, but the important part is this tick method. In this tick method, we are checking the ratio between the current time and the total amount of grab duration. This ratio will define how much we proceed from this location. Let me choose another color, maybe. From this location to here, and if here is 0 and here is 1, then at each location we have different ratios, and accordingly we can transfer between these two positions. This ratio will help us to define the location that we would like to set for the actor location and actor rotation. But first of all, we can easily move the objects to the hand location, but it makes some problems, as you can see in this video. In order to avoid this problem, we need to first rotate the object according to the final position that we first save the hand rotation at each tick, maybe loop, and then we are lerping between the current placeholder rotation and the hand rotation ratio, and we will set the actor rotation according to the value that we calculate from the lerp minus the amount of relative rotation that we have from the placeholder. We should do the same things also for the location. We get the location of the hand, and then we are lerping between the location of placeholder and the location that we have. Then we should calculate the final location according to this lerp value and minus the relative rotation of that placeholder, because placeholder has a relative location based on our actor. If we do these two things correctly, our object should move exactly from this position to the hand position in the shape that we need it. And in each tick loop, we are updating our current grabbing or gravity grab time based on the delta time that we have, and we are checking if the ratio is over than 0.99. It's just threshold that I defined. The object should be grabbed by the hand, and we are attaching that one to the hand. Otherwise, it will continue with this loop. And when we reach this condition, we switch to the grab, and this grab will define into this if condition that avoids tick to loop over the other parts of it. And that's it. With this simple implementation, we can have very interesting gravity grab. However, as I mentioned, you can have also more interactability for this grabbing feature, but maybe we will implement them in the next episodes. Thank you for your time. I hope you enjoyed it. See you next time. Bye.